ground for operations. Otherwise, a load chart would be meaningless. For example, this truck crane is set up with no load and the boom at an angle that balances the crane. The weight of the crane is evenly distributed among all outriggers. This scene provides a below-ground view of the pressure being exerted. The bar graphs, located at each outrigger pad, indicate the amount of pressure being exerted on the ground by lengthening and shortening as pressure changes. As the crane rotates, these pressures change. Lifting a load increases the amount of pressure. Moving the load to a longer radius increases the pressure even more. The red cylinder below the outrigger pad represents the concentration of ground-bearing pressure. Crane manufacturers design pads that can support outriggers on ideal foundations such as concrete. In less than ideal conditions present on most job sites, blocking or mats are needed to distribute ground-bearing pressure over a larger area. This graph now illustrates the reduction in ground-bearing pressure when blocking or mats larger than the outrigger pad are in use. The operator must set up for the maximum possible ground-bearing pressure, as shown in this example. The crane is loaded at maximum capacity, and the boom is at its longest length. Mats work much like snowshoes, and as a result can create firm, level ground. Snowshoes distribute a person's weight effectively and allow a person to walk easily on a surface of soft snow. Similarly, mats distribute a crane's weight across a larger surface area and prevent the crane from sinking or becoming unlevel. Mats, steel plates, timber pads, or concrete rafts may be used, depending on the particular situation. Timber mats can also be used to supplement ground stability when crawler cranes are to be used. Typically, 20 to 30-foot mats are used. Timber mats, when properly constructed, are bolted together to ensure that the timbers work as a unit. If the timbers are free to separate, they are likely to do so on soft ground. Bolting mats ensures that the weight is distributed across all of the timbers, thus reducing a crawler crane's tendency to rock when operating on soft ground or when raising or lowering long booms. Sometimes, however, even mats cannot compensate for poor ground conditions. Lifts should not be made until an area has been properly prepared for the mats. Preparing a site also means ensuring that a structure is capable of adequately handling the crane and the load. Each project must be planned with the maximum load and the full range of equipment in mind. The ground or structure must support the lift, and the minimum distance requirements from power lines and other obstacles must be maintained. The work area must also be cleared to allow for safe operations. Adequate space to erect, extend, and swing the boom must be provided. A minimum of 2 feet of swing clearance between the counterweight and other obstacles is required to ensure that people cannot accidentally become trapped between the crane and another object. The use of outriggers is recommended for every lift. Pads must be attached to the outriggers with keepers in place. If pads are not attached to the outrigger, the pad opposite the load may separate as the crane swings or if the crane frame twists. After any such incident, the cylinder ram may not re-engage the pad. This results in a loss of support. When setting up a crane with mechanical outriggers, the outriggers must be pinned or locked in place. The stability of outriggers is far superior to the stability provided by tires. As many as half of all mobile crane accidents result from improperly set up or unused outriggers. Many times, operators cut corners when setting up a crane. They only extend outriggers on the side or end over which the lift is to be made. However, when only 2 outriggers are set on a load side, a crane has no resistance and can easily overturn in a backward motion. A sling breaking, a load being set down too quickly, or a sudden gust of wind could cause the crane to overturn. When using outriggers, all beams must be fully extended. If all beams cannot be fully extended, on-rubber capacities apply, unless midpoint outrigger extension points are specified by the manufacturer. Depending on the manufacturer's specifications, all tires must either clear the ground or be free of crane weight. The safest way to ensure that tires are free of crane weight is to clear the ground. However, under no circumstances should the tires be raised higher than is necessary to level the crane. When a crane is set up on outriggers, the floats bear the total weight. Specifically, they bear the gross vehicle weight, the load, the rigging, and the weight of dynamic forces, such as movement and wind. At times, one outrigger may bear most of the total operating weight. Outrigger floats are relatively small, however, and a small float coupled with a large operating weight causes extreme ground pressure. Most people assume that if a building is being erected on a site, that same ground should have no trouble supporting a crane. In the case of a building, however, the weight is distributed across a large area. For example, the weight of an average-sized warehouse places only several hundred pounds per square foot of pressure on the ground. A crane's weight, however, is spread over a much smaller area. The maximum ground-bearing pressure of this truck crane is, in contrast, thousands of pounds per square foot. The soft ground around most sites cannot withstand such pressure. Typically, the ground will deflect or sink. Blocking is designed to distribute the load over as large an area as possible. Blocking must be rigid, tightly spaced, and a minimum of 3 times larger than the float area. Support the float. Be level and set square to the cylinder. If blocking is not level, the float socket can fail. The blocking can be pushed out, or the crane can slide off the blocking. Some cranes will merely raise the tires free of crane weight, even on level ground. Others, such as the RT crane, have longer outrigger extensions and can achieve greater variations of level up to a specified point. More than one layer of blocking can create unstable conditions. If multiple layers of blocking are needed, precautions must be taken to ensure crane stability. In such cases, blocking must cover a much larger area than single-layer blocking. If blocking is built up to obtain a particular height, the blocking must be stable and must not topple during swinging, braking, or any other crane operation. Blocking should not be used under the outrigger beams or carrier. Outrigger beams are designed to be supported from end to end. Use blocking only under floats. Span blocking must be avoided. One major crane manufacturer states that span blocking can reduce capacity by as much as 50%. With span blocking, a float is subject to bending, shearing, and cracking. During assembly, the erection crew must ensure that each crane component has arrived at the site undamaged. The crew must also familiarize themselves with the manufacturer's specifications for crane assembly and erection, and follow those specifications precisely, unless being directed by the manufacturer's representative. Inspect the crane according to applicable OSHA regulations and ANSI standards, and according to the manufacturer's specifications, which includes inspecting recently purchased equipment, new and used, and rented equipment, repaired, modified, or overhauled equipment, reassembled equipment, such as equipment that has been stripped for transport. Double-check assembly and all systems. Equipment that has been out of use for 6 months or more. Equipment that has been involved in a crane accident. If one step of the crane setup process has been determined to be the most critical to safety, it is the leveling of the crane. The target levels provided on most cranes should only be used for initial setup leveling. Placing a carpenter's level on the upper works ensures an accurate level reading. Levelness should be checked over the rear and over the side. For a load rating to be accurate, a crane must be level within 1% of level grade. For example, For 100 feet of boom, the load line should be within 1 foot of either side of the center line of the boom. For precision or final leveling, the level of the crane can be checked as follows. The hoist rope can be used as a plumb bob to check the level. The crane is level when the hoist rope is reeved into the center sheave and the hoist rope aligns with the center line of the boom. To check level from side to side, swing over the front or rear and use the plumb bob procedure. The level of the crane, front to rear, can be checked by swinging over the side and repeating this process. A crane operator should check a crane's levelness frequently. Standard operating procedures alone may cause vibrations or shifts that can cause a crane to become unlevel. A lift, particularly a near-capacity lift, should not be attempted if a crane is not level. Note, crawler cranes and cranes operating on rubber cannot be leveled. Instead, the ground should be as level as possible before the crane is blocked. One advantage to using crawler cranes when operating on poor soil conditions is that bearing pressure is spread over a much larger area. Crane setup is vital to safety. Crane setup considerations include selecting the proper crane, determining transportation needs, compacting soil, setting the crane up on firm, level ground, using hardwood mats or blocking, avoiding setup in hazardous areas, using barricades, inspecting the setup and the crane. Imagine being able to ask people involved in an accident whether they would do things differently if given a second chance. The obvious answer, of course, would be yes, because there is always enough time and money to do a job right the second time. Mistakes on the job site are costly in terms of personnel safety and equipment. Achieve high levels of performance. Set up properly for each job. It's a standard requirement, and it's smart business.